Hello and welcome to Pharma Television News Review here at the 4th Midkine Symposium in Budapest in April 2016. On this show I have Angiogenelia Papadimitriou, who is a professor at the University of Patras in Greece. Welcome.
Thank you very much, Finan. I'm glad to be here.
It's great to have you here because you work on the Midkine family. You particularly work on the Pleiotrophin, and you particularly are interested in angiogenesis and its role in angiogenesis. So just give us a brief description of your actual research field of interest.
Okay, well, I started with angiogenesis. Since I started research, I got involved with angiogenesis, and at some point, actually, when I got the junior faculty position at University of Patras, a colleague came up to me and, they were interested in Pleiotrophin and angiogenesis. So that's how I got in this field,
right,
with Pleiotrophin, and work since.
Okay, that's good. So could you describe to us what Pleiotrophin actually does in its role in angiogenesis?
Well, that's an interesting story because we started with Pleiotrophin, and we found since the beginning that it has an angiogenic effect.
Right.
However, this effect was always small, at least smaller than the angiogenic effect of, let's say, vascular endothelial growth factor, who is the angiogenic molecule. So this was interesting and puzzling at the same time.
Right.
So now, after many years of research, we insisted on the field. We found that it can be both pro and anti-angiogenic, depending on the balance between the two growth factors.
Right.
And this is the interesting findings that we have,
right,
and we enrich them.
Right. So obviously there are, as you mentioned already, different factors involved, and so in relation to Pleiotrophin, does it play a dominant role, or is it just a modulating role?
Well, it seems to be a modulating role, which is also very important, because what it does is that it inhibits the excess angiogenesis caused by VEGF and maybe other factors, I don't know, at least yet. But by itself, it still has a small angiogenic effect. So when there is a need to slow down angiogenesis, when it is excess, and that's pathological,
yeah,
Pleiotrophin has this inhibitory modulating role.
Right.
On the other hand, where there is no other factor or other factors are inhibited, then it plays a role in balancing again the system and inducing to a small extent angiogenesis.
Right. I suppose there's two sides to this. One is how you take something like this forward from a clinical perspective, but just going back to the molecular level again. So what is the interrelationship? I mean, obviously there's receptors involved. So in your research and where you've got to so far in your research, what is the relationship between the various receptors, and what role does Pleiotrophin have?
Well, that's another interesting part of our research, because we recently found that VEGF, the angiogenic growth factor, also acts through the phosphatase zeta receptor that is for many years believed to be the Pleiotrophin receptor.
Right.
So now we have recently seen that it is also a receptor for VEGF, and VEGF signals through this receptor. And some of the VEGF actions are not mediated by its classical receptors, but go through this phosphatase zeta receptor. And from the therapeutics perspective, maybe this is interesting because by targeting this receptor through Pleiotrophin or other molecules that could be developed, then we could modulate actions of VEGF that are not inhibited by the existing drugs at this point,
right,
such as bevacizumab. We've seen that it doesn't affect actions through the phosphatase zeta receptor.
Right. So there is scope for another approach, a new approach to preventing angiogenesis.
There is scope. Well, we think that this target is a good target to develop novel molecules
Yeah.
in order to supplement the existing anti-angiogenic therapies.
Yeah.
In cases that they're not effective, in some patients, for example, that they have shown no effect, or
Right.
in cases where there is a resistance,
Right.
maybe because through the phosphatase receptor there are other pathways and other molecules getting involved in this play.
And in those patients that have that resistance, is there any indication that Pleiotrophin is playing a role in that to any extent?
Well, nobody has looked at that yet. It's a very recent finding. What we
Right.
know, though, from in vitro, of course, models, so we have to verify it in vivo in patients maybe, is that when we use bevacizumab and we treat endothelial cells with or glioma cells with this antibody, we get increased expression of pleiotrophin.
Right.
So this could be a mechanism of resistance.
Right.
We don't know. We have to validate that finding. Okay.
So at this conference, we're looking at Midkine and Pleiotrophin. Is there anything you've learned from this conference that helps you in your research?
Yes. First of all, I'm happy to see that we get similar data with many of these people here.
Right.
And we see that these two molecules seem to be very interesting and have a modulating role in many different pathologies.
Right.
So this is one good thing. The other thing is that they also have differences, and this can be exploited in different systems. So one or the other can play a significant role.
Right. They're definitely both round, and they're doing things which, and obviously it's not that they're benign. They're actually quite active in their specific roles, both Pleiotrophin and Midkine.
Yeah, well, to me, one important aspect for both of them is that in the adult, they are not highly expressed.
Right.
So while in several pathologies, we see that they are overexpressed.
Right.
So this makes them interesting targets,
Right.
because that means that they may not affect the normal functions in other systems
Sure.
that are not affected.
Right.
And they're complementary to each other. So if we can discriminate in which systems the one is more important than the other, and we can target the one or the other, that would be perfect.
Yes, indeed. Just back to your own research and where you want to go forward. What's the next stage in your research?
Well, now that we have found these new actions or maybe ligands for the phosphatase receptor, we want actually to try to see how exactly they interact with the receptor. We have some indications that we have different receptor isoforms. So we are going to clarify this point by overexpressing the different isoforms and clarifying the signaling pathways from each isoform. And we hope that this will solve some of the contradictions in the literature, in our work as well. Okay. And this will give us a better and clear view of how to target the receptors as well as the growth factors.
Well, we wish you all the luck with that. Thank you very much indeed for coming on the show.
Okay, thank you very much as well.